Okay, in this video we're going to talk a little bit more about probability, and we're going to start out by talking about something called compound probability. And a compound probability is just a probability involving two or more events. For example, event A and event B. So up to now, all the probabilities we've been calculating are just the probability of one thing happening. Well, we're getting ready to talk about probability that two or more things, two or more events will happen. So for example number one here says, what is the probability of flipping a coin twice and having it come up heads both times? Well, we've already talked about flipping a coin. If we flip a coin just one time and we want to calculate the probability that that one coin flip will result in heads, then this is just the number of ways that this event can happen divided by the total number of outcomes. And for flipping a coin, this is not that hard to calculate. The number of possible outcomes, it's either heads or tails, so we only have two outcomes. And there's only one way that this particular event can happen. It can only come up heads one way, so our probability then is 1/2. Well, if I want to know the probability of flipping a coin twice and having it come up heads both times, this is a compound probability. And notice that I could write this probability statement as the probability of the first flip is heads, and the probability that the second flip is heads. And this just kind of highlights the fact that I'm talking about two events here. So let's take a look at this. How many different possible outcomes are there? What's the total number of outcomes if I'm flipping two coins, if I'm flipping or flipping the same coin twice? So I could get heads on the first flip, and I could get heads on the second flip. Or I could get heads on the first flip and then tails on the second flip. I could get tails on the first flip and heads on the second flip. Or I could get tails and tails. So these are all of the possible outcomes that I could have. So I've got a total of 4 possible outcomes. So then, using my probability formula here, my total number of possible outcomes would be 4. Well, what's the number of ways that this particular event can happen? That is, my first flip comes up heads and my second flip comes up heads. Well, the number of ways that that could happen is just one of those 4 possible outcomes. It's this first one here. So there's only one way that this particular event can happen. So the probability, this compound probability of these two events, is 1/4. Now, there's another way that I could go about calculating this probability, and when we have more complicated probability problems, the second way is often easier. Notice that if I write my probability this way, the probability of this event and the probability of this event, if I look at just the probability of this first event, the probability that my first coin flip comes up heads is going to be 1/2. That's this probability right here. The probability of my second coin flip coming up heads, it's also 1/2. Well, if I take each of these two individual probabilities and if I multiply them together, then I get 1/4, which is the probability of both events happening together. This is something called the multiplication rule. And notice that this is going to be important when we're using the multiplication rule. Notice that both of these two different events, this first coin flip and the second coin flip, notice that neither one of these events has any effect on the other one. In particular, this second coin flip, whatever I get on my first coin flip, it doesn't have any impact at all on this second coin flip. That's what we call independent events. So the multiplication rule just says that for two events, call them event A and event B, if the events are independent, then the probability of both events happening is just the probability of the first event times the probability of the second event. Now, let's take a look at an example of how this multiplication rule is used in this other type of situation that involves something called replacement. So take a look here at example number 2. It says a bag contains 4 blue marbles, 6 green marbles, and 3 yellow marbles. This is the beginning of an example that we saw in the previous video. Now this time, however, instead of just drawing 1 marble, we're going to be drawing 2 marbles at random. So it says if 2 marbles are drawn at random from the bag, what is the probability of drawing a green and a yellow marble? Well, it turns out there are 2 possible answers to this question. That is, there are 2 possible probability values that we could calculate, and it depends on whether we're talking about drawing these marbles with replacement or without replacement. And replacement just means, since I'm talking about 2 events here, I reach in the bag and I draw my first marble. Do I put that marble back in the bag before I reach in and draw the second marble? If I do, then that's called drawing the marbles with replacement. If, however, I take the first marble out and I don't put it back in the bag and I reach in and draw my second marble, then in that case we're talking about without replacement. So let's see how we go about calculating these probabilities in both of these cases. If I'm doing this, if I'm drawing these 2 marbles with replacement, then essentially what I'm talking about is my 2 events, the probability of drawing a green marble and the probability of drawing a yellow marble. And if I'm drawing the first marble and then putting it back, replacing it, and then drawing my second marble, well, notice that drawing the second marble, the probability of drawing the second marble, it's not going to have, the probability of drawing the first marble is not going to have any effect on the drawing of my second marble. In other words, when I'm talking about with replacement, my events are independent. So, for this example, the probability of drawing a green marble on my first draw, let's see, I've got 10, 13, I've got a total of 13 marbles. So the probability of drawing a green marble is going to be, I've got 13 marbles altogether, and I have, how many green ones? 6 green ones. The probability of drawing a green marble is 6 over 13. The probability of drawing a yellow marble is going to be 3 out of 13. And remember, it's 3 out of 13 because I'm doing this with replacement. After I drew my first marble, I put it back before I reached in to draw the second one. So I can use my multiplication rule with these 2 independent events, probability of my first event times the probability of my second event, and that gives me 18 over 13 times 13, which is, I think, 169. And that's going to give me a probability of 0.107. Now let's see what's going to happen if we do this same drawing of the marbles without replacement. So here, again, I'm talking about the probability of drawing a green marble and the probability of a second event. Well, the probability of drawing my green marble is going to be the same as it was before. The probability of drawing a green marble is just going to be 6 out of 13. But now my second drawing, now I'm going to draw, I want to know what's the probability of drawing a yellow marble. But now I'm talking about what's the probability of drawing a yellow marble given that I've already drawn a green marble. And this is a notation that means the probability of drawing a yellow marble given that you've already drawn a green marble. In other words, since we're doing this without replacement, this probability is no longer independent. The probability of drawing the yellow marble for this second drawing, it depends on what happens in this first drawing. So the probability of drawing a yellow marble, given that I've already drawn a green marble, well, since I've already drawn a green marble, I'm not putting it back. That means that I no longer have 13 marbles in the bag. Now I have 12 marbles in the bag. How many of those 12 marbles are yellow? Well, let's see. For my first event, I drew a green marble, so I still have 3 yellow marbles in the bag. I have 3 yellow marbles in the bag, a total of 12 marbles, so the probability of this second event is 3 over 12. And so if I multiply these numbers out, then I get 0.115. So notice that while if I'm doing my experiment, if I'm drawing my marbles with replacement, then these two events are completely independent. However, if I'm doing it without replacement, that means these events are not independent. And if the events are not independent, then I have to take that into account when I'm calculating this second probability. Now, you've got an example, a part B of this example number 2. I'm going to leave that one for you to do on your own. And again, that involves coming up with two probabilities just like we did here, one with replacement and one without replacement. Now, geometric probability. Geometric probability is just a probability that is found by calculating a ratio of lengths or areas of a geometric figure. So remember, again, the formula for the probability of a particular event is just the number of ways that event can happen divided by total number of possible outcomes. Well, for a geometric probability, the number of ways the event can happen is going to be an area. Actually, the area ones are the ones that we're going to focus on. So we're talking about areas. The probability that a particular event can happen is going to end up being what we're going to call the event area divided by the total area. So let's take a look at this example number 3. Example 3 says, what is the probability that a point chosen at random in this rectangle will also be in this square? So I have this picture of a rectangle, and inside the rectangle is a square. And I want to know, if I choose a point anywhere inside this rectangular area, what's the probability that that point is going to be in the square? Well, since the probability, if I state my probability like this, the probability that the point is in the square, this is my event, right? The probability that a point is in the square. So I want to calculate the probability that a point is in the square, then I want to use my probability formula that I use for geometric probability. So I want the event area divided by the total area. Well, the event is that the point is in the square, so I want the area of the square. And the total area is going to be the area of the rectangle. Well, let's see, the area of the square, let me move over here. The area of the square is going to be 3 times 3, which is 9. The area of the rectangle is going to be 6 times 8, which is 48. And there's my probability. 9 divided by 48, if I write that in decimal, I've got 0.1875. Now, what's the probability that if I randomly choose a point somewhere in this rectangle, what's the probability that that point is going to be now in the shaded area? So all this part that's not the square. Well, once again, I'm going to use this same formula. I want the event area divided by the total area. My total area is going to be the same. It's the area of this rectangle, which is 48. My event area, however, is this shaded part here. And notice that the shaded area is going to be the area of the rectangle minus the area of that square. So if I think about it as this is kind of a square-shaped hole, and I want to cut that hole out. So the area of my event is the shaded part. That's going to be the area of the rectangle. Let's say area of rectangle minus area of the square. So let's see, the area of the rectangle, that's 48, minus the area of the square. The area of the square is 9. So I got 48 minus 9 over 48. And 48 minus 9 is 39. And 39 divided by 48 equals 0.8125. And once again, you have one more example there that's similar to this one. We're talking about geometric probability again here, except now your figure doesn't involve rectangles and squares, but it involves circles. So again, I'm going to leave that one for you to do, and we'll take a look at this one in class tomorrow.